let's wait for a while. Within a span of these minutes, we can start our session. Okay, can we start the session now?
Yes, sir.
Okay, good. I need reply from everyone. Please respond.
Yes, sir.
Okay. Pawan, are you there? Let me know.
Yes, I'm right here.
Okay, all right. Okay. Let's start today's session. Wait a minute, I will share the screen. Okay. Yes. Is it visible now?
Yes.
Okay, all right. So, in today's session, we will discuss about the IP addressing. Okay. Once I want to recap whatever the things we have discussed, I want to recap in a short span. Um, on the first day, the day one, am I audible now?
Yes, sir.
Yeah, guys. In the day one, we have discussed about the some of the key terminologies. Key terminologies. Okay. The key terminologies we have discussed. What is network? Okay. May I write it clearly? What is network? And the second one is networking. Networking. And one more, internetwork. Okay. And the one more terminology is internetworking. Okay. So these are the four key terminologies we have discussed, which are basic required for us. So network is nothing but interconnection of multiple devices. Okay. Those who are new, try to note it. Interconnection of multiple devices. We can call it as network. And networking is nothing but enabling the communication between these interconnected devices. Okay. Are you able to understand? Those who are new. Okay. And the next one is internetwork. Internetwork is nothing but interconnection of, it is nothing but interconnection. Connection of two or more network. Minute. Okay. Now is it okay? Yeah. Internetwork is nothing but interconnection of two or more networks. Internetworking is nothing but enabling the communication between these networks. Okay, these connected networks. We need to enable the communication. We can use the terminology called internetworking. Okay, in the day one, these are the four key terminologies we have discussed. And the next we have discussed about the um, like types of network, types of network. Okay, in types of network, we have discussed about the local area network. In short form, we can call it as LAN. And the next one is metropolitan area network. We can call it as MAN, metropolitan area network. And the one more, the final one is WAN, which is nothing but wide area network. So these are the three different types of network we have discussed. And the one more thing, and we have discussed about the topologies. Topologies. Okay. In this topology, we have discussed what is bus topology, and second one is ring topology, and the third one is star topology. Okay, and the fourth one is mesh topology. Okay, these are the four different topologies we have discussed. Nothing but how the data is communicated between the one system to another system. And in the so I can briefly tell you again. In the bus topology, we have a centralized channel. Via that channel, we are communicating between two devices. So too much of content. Bigger, yeah. Okay. We have discussed this topologies concept. Now, is it okay? The first one is bus topology. In the bus topology, what we have discussed, we have a centralized channel. Via that channel, we are able to communicate with the other devices in the network. Okay. And the second one is ring topology. Ring topology. In the ring topology, we are communicating with other devices in a circular path. Okay. Where the devices are connected to its neighbor and forms a circular path. The communication happens in the circular path in the clockwise direction. And the next one is bus ring topology, and the next one is star topology. The star topology, there is a, you can see the diagram here. There is a centralized device. You can name it as switch. Okay. To this switch, multiple PCs will be connected. Okay. This star topology is generally used in the enterprise level. Okay. And the next one is mesh topology. Okay. In the mesh topology, we have discussed what's the advantage and disadvantage of mesh topology, where every device is connected to other device. Okay, it has a multiple paths to reach out the device in between. If there cable, any kind of cable failure also, we can reach out the destination via other path. Okay, and we have seen what's the disadvantage of the mesh topology on the day one session. Okay, and we have seen, we have discussed about the um, setting up a network, setting up a network. Okay, we have discussed about the NIC card, and next one is media and cables. Cables used in LAN, like straight through cable, crossover cable, cross cable, and one is rollover cable. Okay, so in the day one, we have discussed all about this key terminologies and types of network and types of topology. And in that, we have discussed bus, ring, star, mesh topology. And coming to the setting up a network, we have discussed NSE card, media, and cables used in that. Okay, in the today's session, we'll discuss about what is IP address. Okay, in the today's session, we will discuss what is IP address. To get this into your mind, let's take a small scenario. Okay, okay. So what is IP address? Let's say you want to communicate with your friend, you want to send a certain letter to your friend who lives in the another city. Let's say he lives in the Bangalore. Okay, then what you do, you generally write something regarding you or the matter you want to say, and you just post it up, right? What you do there, you include your friend's address, right? So what happens, the post office delivers the whatever the letter is there to the right person, right location, which means your friend, right? At the same time, here IP address is nothing but it's a logical address. IP address is nothing but it's a logical address. If you're any of your maintaining notes, please note it down. It's a logical address. Okay. This logical address basically used to identify the device in a network. Identify device in a network. Are you able to see this? Okay. Identify device in a network. Okay. So in this IP address, bit larger size. Yeah, Suresh Naik, definitely. Okay. Identify a device in a network. So here the IP address, IP nothing but IP stands for the Internet Protocol. Internet Protocol. Internet Protocol address. We have in this IP address, we have two different types. One is IPv4 and the one more is IPv6. Nothing but Internet Protocol. Wait a minute. Okay, Internet Protocol. Version 4. And this is same. Internet Protocol version 6. Okay, this is version 6. So in this today's session, we will discuss about the IPv4. What is Internet Protocol version 4? Okay. So coming to the IPv4. IPv4. This IPv4 generally represented in the form of 32 bits. It's a 32 bits binary representation. Okay, let me open you the slide. IPv4. So bit is nothing but either it's a value of 0 or 1. Okay. IP address is in the form of 32 bits. IP address is in binary representation 32 bits. It looks like this. You can see here 32 bits. Altogether, if you count this, you will find out the count of this is 32. Okay. Count is 32. You can see it like this. And these 32 bits are divided into 4 octets. Okay. What's the reason behind dividing into 4 octets? Let's know that. See, this 32, remembering this 32 bits, is it easy for us as a human? Can we remember these 32 bits? Let me know reactions. Give thumbs up reaction and kind of. So I will.
No, sir.
No, right? Yes. You can see here 0 1 0 1 0 1 0 1 1, all 5 zeros 1 0 1 0 1 1 like that. Remembering this is quite difficult for us. So what they have done is that these 32 bits are divided into 4 octets. 4 octet. Octet means 1 octet. 1 octet means 8 bits. Okay. 1 octet means 8 bits. Let's say these 32 bits are divided with the 4 octets separated by a dot. Okay. Like this. You can see here. Whatever the bits are there here, 32 bits representation divided into 4 octets. 4 octets. This is the first octet. This is the second octet. This is the third. And this is the fourth octet. Okay.
Excuse me, sir.
Yes.
Sir, this IP address like 0101, we have to remember all these 4 octets, or how to remember this, sir?
Yeah. Coming. The next slide. I mean, the next point is that I will
Okay.
tell you. I will let you know. See, this is the first octet, and this is the second and third and fourth octet, right? Which are separated by a dot. Okay, separated by a dot here. So still remembering these octets are quite easy. Remembering these 8 bits. Is that easy for us?
No, sir.
No, right. It will be quite complex for us to remember these 8 bits. Here 8 bits, and the fourth octet also we are having 8 bits. Okay. You can see the first octet, second octet, third octet, and fourth octet. So to remember this thing, what we are going to do, we are converting these 4 octets into the decimal format. Okay, we will see the conversion, how we are going to convert this in the decimal format. What's the value here? 0101. Try to okay. Wait a minute. let's see how to convert this into the decimal format. Okay, how we are getting this value? Let's find out. Let's find out this. Okay, so what's the value we had there? I mean the 4 octets. You can see, I mean the first octet here, first octet, you can see it as, we had a value of 0 1 0 1 0 1 0 1, right? 1 2 3 4 5. Yeah, 8 bits here. And the second octet, what's the value we had? It's all 5 zeros and 1 0 1 in the second octet, subtracted by a dot. We will take one octet and see how to convert that into the decimal. Okay, is that okay for everyone? Yeah, okay. Let's see. To convert from the binary to decimal, binary to decimal. So in binary representation, we have base as the 2. Okay. Why base as 2? Because we are only having 0 and 1. The count is 2 here. So we are considering the base as 2 here. So in the binary to decimal conversion, let's take the first octet, which has a value of 0 1 0 1 0 1 and 0 1, right? Now for this conversion, you need to write the power value of this. So we can take the power value as 2 power 0. We will start from the 0th position, and 2 power 1 this one, and this as 2 power 2, and this one as the 2 power 3, 2 power 4, 2 power 5, 2 power 6, and this is 2 power 7. Okay, let's draw the power table here. Power table. Okay, let's see here. So what's the value of 2 power 0? What's the value of 2 power 0? It's 1, right?
1.
Yeah, good. And the next one is 2 power 1 is, we have the value as 2. And what's the 2 square?
4.
2 square as 4. 2 cube, 8. 2 power 4, 16. And next one is 2 power 5, where we can say the value is 32. Okay, next one is 2 power 6. What's the value 2 power 6?
64.
64. Yes, good. 2 power 7, we have the value of 128.
128.
Okay, let's make this into the binary now, decimal form. Okay, so wherever the value is 1, consider these values: 1, 2, 4, 8, 16, 32, 64, 128. Means, or you can say, so here we have the 0 value, right? Okay, 0 into 2 power 7, what's the value will get? 0 into 0 only, right? And 1 into 2 power 6, what's the value? 2 power 6. 0 plus, here 2 power 6 is 64 value, right? Are you getting this? Plus, you can see 0 into 2 power 5. What's the 2 power 5 value? 2 power 5 value is 32. 32 into 0 is 0. Okay. Plus 1 into 2 power 4. What's the 2 power 4 value?
16.
16. Right. 1 into 16 is 16 here. And next, 0 into 2 power 3, absolutely it will be a 0. You can write here 0. And 1 into 2 square, it will be 4. And 0 into 2 power 1, what the value will get? We'll have 0 plus 1 into 2 power 0. What's the value? 2 power 0 is 1. 1 into 1, we'll having 1. Now add all these values. This is the second step, this is the third one, and the fourth one. Now add 64 plus 16. 64 plus 16 plus 4 plus 1. What's the value you're getting? Yes? 4 plus 1, 5. Right? This is 21. 21 and 3. All
81.
together we are having 85. Okay, 85. So this is how we are converting the 1 octet into the decimal format, right? Now remembering this 85 is easier or not? Okay, let me know, please. This is how we convert from the binary to decimal. This is only the first octet we are converting, and later we have the second octet here with this, and again third octet and fourth octet also. We need to convert them also. You can see here the first. So after conversion, we are having a value of 85. Now, is it easy for us to remember this 85.5.191.1 compared to the previous one? Is that easy?
No, sir.
Yeah, compared to that, it is quite easier because instead of remembering all these zeros and ones, we can remember in the form of decimal. Okay.
Okay.
Compared to the binary, we can say it's quite easier. So all this IP address now we can remember in the form of this decimal format. Okay. This is how can we convert each octet, individual octet to the respective decimal format. Okay. This belongs to the first octet, and this value is the second octet. Can we try the second octet? How to convert this one? Or shall we move to the forward? Shall we move forward?
Shall we move?
Okay. So this is this is the value of second octet, and this the 191 is the value of the third octet, and the fourth octet value is 1 once we are representing. Let's say IPv4 address range. Okay. In each octet, how many values we have? How many bits we have? Each octet.
8, sir. 8.
8 bits. Right? 8 bits. Total that will be in the zeros and ones. So what's the value of 2 power 8? We can say it's a 256. Okay. 256 combination. What it meaning is that 8-bit means you can see here 0, 0, 0, 0, 0, 0, 0, okay, 4, and this one. What's the value of this? Once you convert into the decimal, this is a binary, right? This is a binary. Converting this into a decimal, what will be the value? All zeros. So it will be a 0. Okay. Like that, if all zeros turned into all ones, what will be the value of us? Let's see. Shall we convert that? It should be interactive, not so silent. React at least with the thumbs up emoji. Okay, let's see what's the decimal value of this. Okay, let's say okay. All ones, right? 1, 1, 1, 1, 1, 1, 4. Okay, 4, 5, 6, 7, 7, 8. This is 8 ones. Let's convert this into the decimal. Okay, 1 into 2 power. This is what's the value of this? 2 power 7. 128. 2 power 6, 64. 2 power 5, 32.
32.
Yes. 2 power 4, 16. 2 cube, it's a 8 value. The value is 8 here. And this will be the 4. And this will be the 2 square, or 2 power 1, it's a 2. And 2 power 0, it will be 1. Or you can note it down like that: 2 power 0, 2 power 1, 2 power 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 5, 2 powers 2 power 6, and we'll have 2 power 7, right? So these are the values of bit. Wait a minute here. Okay. Yeah. So what's the binary bits we are having? It's 1, 1, 8 ones, all 8 ones. Let's see what's the value of 8 ones. The first one is 2 power 0. What's the 2 power 0 value here? 1. 1. 2 power 1 value is binary to, yeah, binary to decimal conversion. This is a binary representation. Let's make it to the decimal conversion. Here's a 2. And this will be 4. And this will be 8, right? And what's the value of this? 16. And 2 power 5 value is
32.
32. And 2 power 6 value?
64.
64. And 2 power 7 value, this one is 128. Now add all these values. What the value you are getting? Comment. Try to add all these values.
256.
To
56.
256. Wait a minute. Yes, someone posted. Wait a minute, I will open the chat. Two 56 value. Once again, so when you are having the one odd value here, it's a 1. Once again, recalculate it. Altogether, we're having a value of 255. If you add all this value, you'll get a value of 255. Okay. So talking about the IPv4 range, we'll discuss IPv4 range here. IPv4 range. Now you know how to convert from the decimal to, from binary to decimal conversion. You came to know how we convert. In the IPv4 range, how many octets we have? 4 octets. Okay, 4 octets. This will be the, let's say, this is the my first octet, second, which is separated by a dot. Okay, second octet separated by dot, third octet again separated by dot, and here we have the fourth octet, right? And what, how many combinations we have in each octet? Combinations in each octet, how many bits we have?
8 bits.
Octet 8 bits, right? Correct. What's the value of 2 power 8 you are getting? The value of 2 power 8 is 256, right? Okay, but you can see here, as we are starting from the 0, we are having a value up to 255. In between we have 1, 2, 3, like that, up to like you can have up to 255, 254. So all this together you will get a count of what? 256 combinations. Got the point? In the IPv4 range, we are having 4 octets. In each octet we have 8 bits. 2 power 8, we have the 256 as a combination. As you are starting from the 0, you need to represent the 0. Starting from the 0, you will go up to 255. And you can see the total count as 256. And then the second octet also, you are having same. It will be from 0 to 255, separated by a dot. And the third octet also same, from the 0 to 255. Fourth octet, as usual, 0 to 255. So this is the range of IPv4. This is the range of IPv4. Okay. So if you see all these combinations, so in total we are having how many bits? 32 bits, right? IPv4 represented as 32 binary bits. What's the value of 2 power 32? It's around 4.3 billion. 4.3 billion. So 4.3 billion IP addresses we are having. Okay. Have any of you calculated this one? Yeah. Okay, Rao. Well, if you calculate this 2 power 32 value, you will get around the 4.3 billion IP addresses. Okay. In this, we have all these 4.3 billion IP addresses. So as a network admin, can you able to handle this, all this 4.3 billion IP address? Is that much easier for you?
No.
No, absolutely no. So here comes a purpose. We can call it as, we can say, classification of IP addresses. I can share you the document here. So this is how we convert how many combinations we have in one octet. This is how it looks like. Okay. See, you can see here the total IP address range is from 0.0.02 255.255.255.255. Okay, this is the total IP address range. Here you can see some of the conversions, how you can convert. Okay, let each of you do these conversions. I will help you here. What you need to do here in the first one, wherever the places you can find the 1, you need to add those values. Okay, and you can convert the binary into the decimal here. Are you able to see now? Okay. See, now convert this one. The first one. What the value we are getting here? Try to add. If you add the value of 128,
192.
192. Great. The next one. Add up this.
10.
What's the value you will get? 10. You can see the values. This is the 192. The first one is 192. The third one, convert everyone. You need to add 128 and 32 and 8. What's the value you are getting?
168.
168. The next one. Try out next one.
$156.
156.
Last one is 16.
Yes. Sorry, it's getting the 172.
Oh, sorry.
Yeah, once recalculated, you need to add 128 here, 128, and the next one is 32. Okay. And again, 8 and this 4. 8 and 4, the value will be 12. Right?
Yeah.
This will be 2. And you're adding 7. And here will
Yeah.
172. It's a 172. And the next one is 16. Great. Let's convert from decimal to binary. Okay. How to convert from the decimal to binary? You know the conversion now, right now, from binary to decimal conversion, you know. Let's convert from the decimal to binary. Okay. So what the thing you need to do is, you need to check your decimal value. Here 18 is the decimal value. Okay. 18 is the decimal value. So if the 18 value is greater than or equal to the upper value here, 128, then you need to mark it 1. If not, it is not greater, then you just simply keep it as 0. Okay. Whatever the decimal value is there, if the decimal value is greater than this value, then mark it up 1. Or else you just keep here 0. Let's see this one. With the help of this example, you can understand. So does 18 is greater than 128 or equals to 128? No. So we simply make it 0. And the next one, does 18 is greater than or equal to 64? No again. So what you do? You keep again 0, this one. This one has the 0 again. This will be the 0 and this will be also 0. And the next one, 18 is greater than or equal to 32? No again. This will be 0. Now see here, 18. 18 is greater than or equal to 16. So what you do? Simply make here 1, mark it 1. This one. And the remaining one. Now what you need to do, you need to subtract this value, 16 value from the decimal number value. What the value you are getting? You will having 2 left over with the 2 value. Now 2 is greater than or equal to 8? No again. So mark it 0. And the other 4 is greater than equal to 2? No again. Mark it 0. Next one. 2 is greater than or equal to 2? Yes. So mark it 1. The next remaining is left over. So what you do again? Minus from this. You will get a value of 0.
Excuse me, sir.
Right? Yes.
Sir, how you are assigning this 0 randomly, sir?
Randomly. See, the condition is that whatever the value, decimal value you are having, you need to
Yes, sir.
check out with these values.
Okay.
Okay.
Yes, sir.
Okay.
Okay.
Okay. Or else I will show you one thing here. Wait a minute. I will show you for the clear purpose. Okay. So what's the value here? We are having 128 means 2 power 7. This is 2 power 6, 2 power 5, 2 power 4, 2 cube, 2 power okay, sorry, this is 2 square, this is 2 power 1, this is 2 power 0. What's the condition is your decimal value here, if the decimal value is greater or equal to, then you make it this session as the 1. What you need to do, mark it 1. If a decimal value is greater than or equal to this values, then make it 1. Now 18 is greater than or equal to 128? No. So what we do, we just simply mark it 0. Okay. And the next one, you can see 64 is still greater. 18 is still smaller. So what do you do? Still you make it 0. The 32 also greater. And the 16 one. Coming to the 16 one, the 18 decimal value is greater than the 16. So what you do? From 18, you subtract 16. You are left over with the 2. And you need to make it 1. This one as the 1. 2 power 4 as the 1. And this values 2 power 7, 2 power 6, 2 power 5 will be 0. 2 power 4 will be my 1. In the binary representation, it will be 1. And the leftover is 2. In the decimal, we are having 2 value. But see, the 2 value is still less than 8 here. Right? So what you do? Just simply make it 0. Next, 2 is the 2 decimal is still the small one. What you do? Mark it 0. You can see the next one. 2 is greater than or equal to 2, which is satisfying the condition, this condition, right? So what do you do? Just mark it 1. So if you do the value 2 minus 2, it will be getting the 0, and leftover will be no required. So simply mark it 0. You can see the animation here. This is how you can represent. Now, the 18th decimal, this decimal value is represented in the form of 0, 0, 0, 1, 0, 0, 1, 0. Got here? How to convert from the decimal to binary? Yeah. Okay. Sohail. Yeah. Now convert 152 and let me know the values. 152. I'll open the chat box.
Okay. One. Sir, can I tell?
1
Yes.
to 1,
One.
0010.
Anyone.
100 1100.
Sorry, can you speak? Come somewhat slow. 10
10
10
01
01
10
10
00.
00. Okay, let's see this one. Yeah, correct. The next one, do the 200.
Excuse me, sir. Sir,
Yes.
in place of 64, we can place 1 also, no, sir?
See,
Because 64
yeah,
is less than 152.
okay, I will explain that one. Okay. Yes. So what's the power values we are having? 2 power 7, 2 power 6, 2 power 5, 2 power 4, 2 cube, 2 square, 2 power 1, 2 power 0. Respective values are, this is will be the 1 and this will be the my
2,
2, same, 4,
8,
8,
16,
16.
32,
Next one, 32. And this one,
64,
64. And this one,
120.
128. These are the respective values. Okay. So what's the decimal value we have? 150, 152. Yes, 152. This is the decimal value we are having. Now let's check. 152 is greater than or equal to this 128, right? 128. What you do here? You just simply mark 1. Now from 152, remove 128. Got the point? Here 2 and the values will be remain with the 2 and this 2, 4 and 20. So remain with the 24. Okay? Hello. Please respond.
Yes, sir.
Yeah, right now we are having the value 24.
Yes, sir.
Now again, compare this 24 value with the 64 now. 24 is greater than or equal to this 64? No. Right? So what we do? We simply make it 0. Next again. 24 is greater than or equal to 32? We are checking with this value, 32. No, still no, right? So what we do? We mark it 0. Next. See here, 24 is greater than or equal to 16. Please respond. This is
Yes,
S.
sir.
Yes, 24 is greater than or equal to 16, right? Yes. So you will what you do, you can mark it 1. And what you do from 16, from 24, remove 16. Whatever the leftover value, 8. Right? Okay? 8. Is 8 is, now we are having a decimal value as 8. 8 is greater than or equal to 8? Right. Okay? So what you do, simply mark it 1. So, and from 8, remove 8 value now. What you are removing? 0 is a leftover. So the next, whatever the value is there, you can keep it as 0. This is how you are getting 152. And this is the binary representation. Are you getting this? Um, Hello?
Yes, sir, I understood.
Yeah, nothing but see, once you make the values as 1, what you need to do, you need to remove these values from the decimal value. Okay, then you will left over with the sum out value, and you need to compare with the other values, leftover values. Okay, that's how you can convert binary to decimal. All right. So for the 200, this is a binary representation. And for the 15, okay, do for the 15. It's a easier one. Do for the 15. How can you convert this one?
Sir, can I tell?
Yes.
0, 0,
Okay. 0, 0.
0, 0,
Again 0, 0.
1, 1, 1, 1,
1, 1.
1, 1.
4 ones. 4 ones, right? You are saying?
4 ones. Yeah, yes, sir. 4 ones.
Okay. Let's see. Let's see this one. We will track this one. So 15 is greater than or equal to 128? Wrong. No. So what we do? We simply keep 0. Okay. Correct. Next. 15 is greater than or equal to 64? No. So 0. Correct. Again, 15 is greater than or equal to 32? No, again. So 0. Mark it 0. And the next one. 15 is greater than or equal to 16? No, again. Correct. And the next one. What the next one? Next value we have? 15 is greater than 8. Okay. So what you do from the 15, subtract 8. And at the 8th place, make it as 1. This one, correct. Again. Leftover decimal value we have having 7. For the 7 again, we need to check it out. So next one is 2 power 8 is completed. So 4. 7 is greater than or equal to 4? Correct again. We need to mark it 1. Okay, we marked it 1. Now, from 7, subtract 4. Left out value is 3. Now, the decimal is 3. Now, P is greater than or equal to 2. The next value is 2. Okay, again. So, what you do? Mark it 1. Correct this one. And the next one is same. From if you subtract from 3 to, you're getting the remaining decimal value as 1. If you do the 1 is greater than or equal to 1, yes, this is also right. So, this is the conversion of this. Great work. And the 240 conversion is this. Are you able to getting this into mind? Hello, please do respond now. Are you able to convert from decimal to binary? Please respond.
Yes,
Yeah,
sir.
good. Yeah, good, good. Let's see the classification of the IP addresses. Earlier, I have mentioned all together from 0 dot 0 dot 0 dot 0 to what's the combination? 255 dot 255 dot 255 dot 255, right? 4 octets. Okay. Together, how many combinations we have? 4.3 billion. 4.3 billion IP addresses we have. So handling all these IP addresses, is that easy for us as a network admin? Is that easy for us to handle all this 4.3 billion IP address? No, absolutely. It's a no. So what you are doing, we are dividing this IP address into the different classes. So we are having class A, class B, class C, class D, and class E. These are the 5 classes we are having. So because of that reason, we are dividing IP addresses into 5 classes. The class A, B, and C are for the purpose of LAN and WAN. Local area network, wide area network purpose, we are using class A, B, and C. And the next one is reserved for the multicasting. The class D IP address reserved for the multicasting. Okay. And the class E reserved for the research and development. The class E IP address are for the research and development. We will see what is this class A, class B, class C, and class D and class C IP addresses and what's the range of these IP addresses. Okay. Here we can say comes the priority bit is used in the IP address classification. Note, you need to remember this priority bit is used for the IP address classification. Most significant bits from the first octet, this one main point, this is the first octet. We are only considering the first octet. The remaining second and third and fourth, we are not considering these octets in the classification. Okay, we are only considering the first octet. Where the first octet, with the help of the first octet only, we are classifying into different classes like A, B, C, D, E. Okay, you can see for the class A, the priority bit is 0. For the class B, priority bits are 1, 0. We will study about what is 0, 1, 0, and 1, 1, 0. Class C priority bit is, and class D is 1, 1, 0, and class E is all ones, 4 ones. Let's see. Let's see what's the class A range.
Sir,
Yes.
can you back the screen, sir? How you are assigning 0, 1, 0, 1, 1, 0, sir?
Yeah, I will let you know that that one. Okay. What the author mentioned. So we are only considering the first octet, right? We are having this is the first octet separated by the first octet. Second octet. Same third octet, and we are having the fourth octet. we know what's the purpose of classification, because we are having 4.3 billions. Handling those 4.3 billion is quite complex for us. So what we are doing, we are dividing these IP addresses into the different classes, right? In the classification, we are only using the first octet. In one octet, how many bits we had? We had 8 bits, right? Okay, 8 bits. From where it starts? All zeros, 0, 0, 0, 0, 0, 0, 0, 0, 8 bits 0. And where it ends, this all zeros will turn into all ones. In the decimal format, you can say this as the 0, and this will be 255. We have done the conversion of this also, right? See, priority bit is nothing but, so this will be my least significant bit, and this will be my most significant bit. I can call this as right side bit as the least significant bit, and the leftmost bit, I can call it as most significant bit. Here, we are considering the priority bit as the, you can see here also, most significant bit as a priority bit, this one. Okay. So this is my the most significant bit, right? What I'm doing for the class A classification, for class A, what I'm doing here, I'm taking the 0 as my priority bit, which means this will be my 0 only. All this will be my 0. I will show you the animation also. Try to understand here. This all zeros will be turns into the all ones. Now, what will be my decimal value? What will be my decimal value? Let me know here. This is a 64, right? This is a 64. This is 32. This will be the 16, 8, 4, 2, 1. So what's the value you are getting? Simply subtract from 255. Okay. Altogether we have 256 value, right? From that, subtract this value, you will get the value. This value will be the 128, right? What's the value you are getting? From the 255. Sorry, from the 255, subtract 128. If you add all this value, you are getting a value of 127. You are only considering in the classification, you are only considering the first octet. Okay. In the first octet, one octet consists of 8 bits. 8 bits, right? This 8 bits will be all zeros to all ones generally. From here to here, all ones. Okay. Using the first octet only, you are classifying into class A, B, C, D, and E. For the classification, what you're doing, you're considering the most significant bit, which means leftmost bits. These are the leftmost bits, right? In that, I'm considering the value as 0 for class A. For the class A, you're considering as 0. You can see in the next slide, class A ranges. First bit of the first octet, first bit of the first octet is reserved as a priority bit. Value is 0. Try to understand. The first octet is the first octet, 0.0, 0, 0, then 0. Okay. First octet. Up to where we are having 1, 1, 1, 1, 1, 1, 1, again 1, 4, up to 1. All together, how many combinations we have? 256.
256.
256 combinations we have. You can see here in class A, first bit of the first octet. This is the first octet. Remaining here we are having second octet, third octet, fourth octet, right? In the first octet, first bit, this one, most significant bit will be, value will be 0. See this one 0 0 0 0 0 0 0 1. What's the value of this? It will be my 0. If you convert this one, this value will be 1. And if you'll have 1 0 and all this will be my zeros, this will be my 2, right? Like that, the first bit will be, all this bit will be zeros. And these remaining bits will be all ones. If you convert all these ones, what you're having? You're having a value of 127. So the class A ranges from the 0 dot 0 dot 0 dot 0 to 127 dot, and the remaining will be the how many combinations? 256 combinations, right? This is the second octet, third octet, fourth octet. Are you able to understand this one? These values will be as it is up to 255 dot 255. Okay, this is the class A range. Wait a minute. All right. You can see the only first octet you are having the first bit. The leftmost bit we can consider as the most significant bit, that as the 0, and consider this only one octet. This will be own change. This bit is reserved here. Okay. The remaining will be all ones, and you are getting a value of 127. So class A ranges from the 0 dot 0 dot 0 dot to 127 dot 255 dot 255 dot 255. Are you able to understand this one? Let me know in the comment section. Okay. Let me know if you are unable to.
Sir, excuse me, sir. This 0 dot 0 dot 0 dot from top to bottom we have to take, sir.
Yes.
And
Generally, see, I want to let you know. So what's the general IP, I mean, range from 0 dot 0 dot 0 dot 0, right? Up to
yes,
where
sir.
we are having 255 dot
55.
255 dot 255 dot 255.
Yes, sir.
In between, how many combinations? It is a 4.3 billion. Approximately, we are having a 4.3 billion combinations.
Yes, sir.
So to handle all these IP address, it's a quite complex task for us as a network admin.
Yes, sir.
So what we are doing, we are dividing this into the classes. How we are dividing? We are considering the only one octet, this octet, first octet. This is the first octet,
Yes, sir.
right? This is the second octet. But here for the classification, we are only considering the first octet. Generally, this is in the decimal representation. Coming to the binary representation, this will looks like this. This is the binary representation. Okay.
Okay, sir.
Okay. We are
Sir.
considering here answer. Yes.
Sir, last one, why you are taking 127, sir? So up to 255, right? We are taking up to 255, right? So why
Yes.
you are
Yes.
taking the 127?
Here, let me explain you. 127 dot 255 dot 255 dot 255, right? This will be considered as my class A. Why class A? See, the first, whatever the first bit left, I mean leftmost, this one, this bit will be my 0 only. This is reserved. But remaining all these zeros will converted into all ones. All ones. Now add this all ones value. What the value you are getting? This is a 2 power 6 value is
127.
64. Sorry,
Yeah.
2 power 6 is 64.
Yeah, 64.
Now open your calculators, everyone.
Yes, sir.
64. 2 power 5 value is
32.
32. 2 power 4 value is 16.
60 plus 8 plus
8
4
plus
2 plus
4 plus
plus
2
plus 1
plus what's the
1
value you are getting?
127.
127.
Okay.
Now you got the point?
Yes, sir. Yes, sir.
This is how we are dividing. That's, see, this belongs to the class A. Now let's do for the class B. Okay, class B. What's the priority bit for the class B?
128.
First two, okay, listen me here once. In class B, first two bits of the first octet are reserved as a priority bit values as 1 0. For the class A, we are having only 0 as a priority bit, but for the class B, we are having priority bit value as the 1 0. Okay, next let's see the first octet 1 0 0. This will be the 0, and this is again 0 0 0 0 0, right? Okay, right. What's the value for this? 128. Okay, this is 2 power 7 value. All other are 0. So just consider 2 power 7 is 128. So we're having the class B starts from the 128. 128 dot 255, I mean, okay, 0 dot 0 dot 0. And let's see where it ends. The first bits are reserved. These 2 bits are reserved. And the remaining zeros will convert into all ones. Okay. Now convert this one. What's the value you are getting? 1 0. This will be the 128. Yes. Raw, you are correct. 128 plus 1. So what's the value of this? 2 power 5. 2 power 5 value. Let me know. 32 plus this one 16 plus and 1 4 plus and again this 2 plus 1. What's the value we are having? Add all these values. You will get a value of 191. Again the same, the second octet will be remain unchanged. It will be 255, and the third octet again it will be from 0 dot 0 dot 255, and the fourth octet will be 0 to 255. Got this one? Got it? You can see once again. Once a minute. Are you able to understand now? Okay. See, the class B ranges from the 128 to 191. Okay. The first 2 bits here, first 2 bits of the first octet. This is the first octet. Okay. First octet. First 2 bits of first octet are reserved as priority bit. The bit value is 10. This is the 10. These are reserved 10. And these many combinations in between we are getting. Okay. So whatever the values left over here, all these zeros converted into all ones. And you can see the value as 191 here. You can, if you convert this binary into decimal, you will get a value of 191. And the class C ranges, we have the priority bit value as 110. Someone please turn off your mic. And the class C Class C will be from 192.0.0.0 to all the first bits. This 110 will be reserved. Okay. If you convert this value into binary decimal, you will get a value of 223. Therefore, the class C will be ranges from the 223.255.255.255. Are you able to understand? Okay. The class A ranges will be 192 to 223. And for the class D, we have a priority bit value as this 1110 in the first octet. You have the first octet. In the first octet, these 4 values will be 0. Means the varying only. These 4 bits will be the changes. See, all these bits are reserved. Thus, remaining all these 4 zeros will convert into all 4 ones. You will get a value of 239. From the 224 to 239 will be your class D range. Okay. Let's see the class E range. The class E range, the priority bit value is all ones, 4 ones. Okay. Tabasum, can you please turn off your mic?
Oh, sorry, sir.
Yeah. With all ones. See, the first 4 bits, this as result. These are the priority bit. Okay. And these 4 zeros, the remaining 4 zeros, all are turned into the all ones. So what's the value decimal together? If you add all these values and convert into the decimal format, you are getting a value of 255. So the class E ranges from the 240.0.0.0 to 255.255.255.255. This is the class E range. Okay. Note down these ranges. If you are maintaining any kind of notes, note down this. Let me know. Okay. I can explain you once again how the ranges will be.
Sir, can you take back to that slide, sir? I will take a screenshot before this.
Yeah.
Okay, sir. Okay, thank you, sir.
See, simply, I want to tell you one thing here. What's the range? The whole IPv4 range is from 0.0.0 up to where we are having 255.255 dot again 255.255, right? Yes, this is the range we are having. What's the combination? What's the combination we are having? Approximately 4.3 billion. Okay, 4.3 billion. Handling these many IP addresses is quite complex for us. That's the reason we are dividing this into the classes. So how we are dividing these classes? We are considering the first octet, this octet, only this octet, and we are doing the classification. Okay, the first value will ranges from the 127 dot class A 255 dot, and this will be 255 dot 255. This will be my class A, and class B starts from the 128, right? 128 dot 0 dot 0 dot 0 up to where it goes 191. So this remaining will be 255. And class C 192.0.0.0 to 223 dot. This will be remains unchanged. The first octet will be goes on changing. And coming to the class D. Class D will be 224 dot, again 0.0.0 up to where? To 39 dot 255 dot 255 dot 255. This will be my class D. And class E will have a value from the 240 dot 0.0.0. Okay, now you can see how it's differentiated. Yeah, the class A will be from 0 to 127. Class B, try to remember class A from 0 to 127, and the class B will be from 128 to 191. There will be changing only first octet. Okay, and this class C from 192 to 223 will be the range of class C. And for the class D, you are having a range of 224 to 239 is the value. And for the class E, you are having the value 240 to 255. This is the class E range. This is reserved for the multicasting, and this is for the research and development. Abasa, are you getting this one?
Sir, I want to ask you one thing, sir. We have to remember this value, sir. 128, 191. This all.
Yes,
Really?
yes, yes, yes.
Okay.
Yes.
Okay. Okay.
The reason is that, so when you are attending a kind of interview, okay, then they might ask you that. So what's the range of class C? What's the range of class B? Like that.
Okay.
So you need to
Okay.
remember the values. Okay.
Okay.
Try to remember these values.
Sir, I have one more question, sir. If we go
Yeah.
for the job role as a system administrator, so we need to have the knowledge of this also, sir, the CCNA complete course, or some part of CCNA is okay, sir.
System administrator, right?
Windows Server 2025. I have done that course, sir,
Okay.
recently. So if I go as a level 3 IT support, so we need to have knowledge of this whole syllabus or some part of CCNA is okay, sir.
Just a minute. Just a minute. I will be back.
Okay, sir.
Yeah. Can you please repeat it again? I was in
Sir, actually, I want to apply for the position of system administrator, sir. It means like level 3 IT support engineer, right?
okay.
So if I apply for that, I should have the knowledge of this CCNA also, sir. Like complete this course or some part of CCNA, sir.
If it's a part of system admin, then you need to have a knowledge, good knowledge on uh, Windows server, handling Windows server.
This CCNA, sir, this networking knowledge.
CCNA, yeah, it's a networking knowledge is required also to update things.
Oh,
Yeah.
okay. And what is this CCNP
You
course, sir?
have mentioned level 3, right?
Yeah, level 3.
So completing by, so have you done the MCSE in?
Yeah, MCSE, Windows Server 2025,
Mm,
sir. Not
okay.
MCSE, it is updated version, system admin of
Okay.
MCSE, Windows Server 2025.
Okay.
Yeah. And do we have a separate course for CCNP, sir?
You can contact the counselors once regarding this. Okay.
Yeah, okay, sir. Thank you.
So this will be the ranges of the. Note down this one. Okay. Take a screenshot or else. Let's identify the classes. As of now, you know the what are the different classes we have in the IPv4, right? Are you able to hear me? Okay, done. So the first one, the IP address is 10.1.100.1.
Class A,
What's
sir.
class A? Yeah. 192.1.1.1. Which class is that?
Class C.
Class C. Good. 224.0.0.10.
Class D.
Yes. The next one is 120.200.1.1.
Class B.
Class B. 1 second. Recheck it. What's the range of class A, B?
Okay, it's class
A.
A. Class A.
A. Yes. The class A ranges from the 0.0.0.0 to 127 dot.
127.
127.
Yeah, which means we are having here the value 120. Okay, by looking at the this first octet, you can say which class is it belongs to. Okay,
Yes.
150. 150 comes in which range? Class A or B?
Class B.
B. What's the range of class B?
It's from 191 to. It's
128.
from 0 to
128 to
190.
128 to
128
191.
to
191 to
191. Okay,
191.
150 is between the range, so it will be a class
Yes.
B. And the next first one is this 17.
Classes.
Class A.
Class A.
Yes. Good. It belongs to class A, but the thing here is we are having the value 256. Does we have seen the 256 value before in this?
No.
If we are having here some 255, we can say it belongs to the class A, okay, which is a valid one. But now we are having a value of what? 256 there.
256.
So which is a invalid IP address. Okay. What the point? Why I'm saying it's an invalid IP address? In each octet, what's the range? From 0 to 255. Okay. See here. Let's say this is a 17 dot network. 17 dot 1 dot 256.1 they are given. But in actual, what we had, does 256 is a valid one? No. The third octet, we are having values will be the from 0 to 255 only. It's exceeding the limit 256. So we can say it's an invalid IP address. Got the point? Give a thumbs up if you understood. Okay. Next, see the octet format. Okay. So, what are the octet format? We have 4 octets, right? First octet, second octet, third octet, and fourth octet. Okay. We are dividing these octets into the network and host portions. Okay. Which means in the first one, in the class A, we are making it as 1 as the first octet is network portion, and this remaining 3 octets as the host portion. H is nothing but host portion. Okay. And the class B, we are dividing the first 2 octets, first octet and second octet as the network portion, and remaining 2, third and fourth as the host. Okay. And this one, class C, we are having 3 network portions and 1 host portions, which means the first 3 octets, 3 octets as my network portion, and the 1 is host portion. Try to remember this also, octet format. For the class A, having 1 network portion, 3 host portion. For class B, 2 network portions, 2 host portions. For class C, 3 network portion, 1 host portion. You can see class A, number of networks and host. Let's study how many networks are there in the class A. Okay. How many networks in class A? Okay. We had a formula for this. You can see here. So generally, what's the octet format for class A? Having 1 network portion, 3 host portions. Okay, which means in 1 octet, how many bits? 8 bits. So how many network bits we have? 8 network bits, and remaining this 8 and this one 8 and this one 8. All together, how many bits? 24 bits as my host bits. Okay, let's see how many number of networks are there in class A. To get the number of networks, we had a formula 2 to the power of number of network bits minus priority bit. Okay.
Sir, excuse me, sir.
Yes.
Sir, I did not listen to you, sir. Actually, this network bits 8, how can we say, sir? It is 8 and host bits are 24.
In the previous slide, we had this one. You can see here. For the class A, we have
Okay.
1 network bit and 3 host.
3 host bits.
I mean, so not bits, host portions.
Host
1
portion,
network
network
portion and 3
portion.
host portions.
Yes,
For the
sir.
class B, 2 network
2
portions,
network
2
portions
host.
and 2 host portions.
And class C, here you can see 3 network portions and 1
And 1
host
host
portion.
portion.
Yes. Okay. Let's see number of networks. In class A, how many networks are there? Let's calculate. For that, we had a formula 2 to the power of number of network bits. So what's the value, number of network bits? 8. Here we have number of network bits as 8, which means 2 power 8 minus priority bit. For class A, what's the count of priority bit? 0, right? 0 is the priority bit of class A. What's the count value? 1. 0 is the element, right? Number. The count of 1 element, we can say 1. Okay. 2 power 7. What's the value of 2 power 7? 128. We are having 128 networks. Okay. But you need to keep in mind one more thing, that 0 dot 0 dot 0 dot 0 and the last one, class A, ranges up to where? Yes, please
127,
respond
sir.
anyone. 127, right? 127 dot 0 dot 0.0. See, these two networks, 0 dot network and 127 network, these two networks will be this for the global network ID, global network ID, and this 127 network used as the loopback network. Okay, I will see here first how many networks we have. Generally we have 128, but from that the 0.0.0 network and 127.0.0. network, both are reserved. This one, this is for the global network ID. We can see, we will discuss about this network in the default routing. Okay, for of now we will discuss what is 127.0.0 network. Okay, this 127.0.0 network is generally, to get this in mind, what happens, suppose let's say some of you know the web development, right? You heard web development. So those guys, what they do, they generally write whatever the code is, they write on certain compilers. Okay, and they compile the code, and the compiled code will open in the browser. Okay, in the browser you can see it will shows the local host and the IP address will be shown there. I think many of you have seen this one. Okay, we can call it as loopback network. This loopback network, what it does, it won't allows the traffic outside of your machine. This network, this IP, this network is used for the purpose of web development and testing purpose, and we use this. Okay, so you are from the 128, what you are doing, you are subtracting these two networks. 128, you are subtracting 0.0 network, and 127 network you are subtracting -2, because here 1 and this one, all to have two networks are subtracted, you will get a 126 networks. These 126 networks are valid networks. Okay, up to here, no doubt, all okay? Okay, yeah, let's see number of hosts. In host, how many calculations, I mean how many bits are there here? 24. Okay, for this also we are having a formula, 2 to the power of number of host bits minus 2. Okay, you can see here 2 to the power of number of host bits, 24 host bits minus 2. The minus 2 is for the purpose of network ID and broadcast ID. We will discuss what is network ID and broadcast ID in the next slide. If you get this value, if you calculate 2 to the power of 24, you will get the value of 1,677,216. Nothing but 1,67,77,216. Okay, from that you are minusing, subtracting -2. -2 for what? This is the -2 for what? One is for the network address, and another one is for the broadcast address. Okay, one is for the network address and another is broadcast address. So if you subtract, what you get, you'll get a value of 1,67,77,214 hosts per network. Host you can call nothing but end devices, which means this many valid IP addresses are there. Okay, this many valid IP address you can assign for the end devices like personal computers, and if you have any printers, for those also you can assign end devices like PCs, printers, like that. Okay, you got this point? In the class A, we are having 126 networks. In each network, we are calculating how many hosts are there. This will be in each network. In each network. To explain you this, let's say here on 0 dot 0 dot 0 dot 0, right, up to 127 dot 255 dot 255 dot 255 dot again one more 255, right? This is the class A range. Okay, this will be my global network ID. We will discuss this about in the default routing, and this is why, I mean, you can write it down, this 127 network as this one, 0.0.0. Okay, this is a one separate network. This is for the loop back. Okay, here 1.0.0.0 network is a network, and 2.0.0.0.0 is a one more network, and here 3.0.0.0.0 network. Like that, you are having up to 126 dot up to 127.0.0 network. Okay, here we are having total 126 valid networks. The first one is reserved for the global network ID, and the last one is 127 network is for the loop back, right? Remaining 126 networks are there for us. Let's say consider this 2.0.0. network. Okay, for this network, in this network you can have a, how many hosts you can have? 1,67 1 crore 67 lakh 77,000 plus number of PCs you can connect here. Got the point? Okay, I want response from everyone. Open chat box, please do respond. I want to see from each one. Okay, Suresh Nayak. Generally, we are having in the class A, we are having how many networks? 126 networks. If we take one network, I am here considering this 2.0.0. network. In this network, how many end devices I can attach? 1 crore 67 lakhs 77,000 plus devices I can attach. Okay, got this point? I need from everyone. Still some more not responding. Balraju, Soliddin. Okay, let's see the class B. In the class B, we are having two network portions, two host portions, right? Which means altogether this 8 bits and this 8 bits means nothing but 16 bits as the network bits and remaining 16 bits as the host bits. Altogether, how many? 16 plus 16, 32. Okay, altogether we are having 32 bits. So number of networks for this, you can see for the number of networks, 2 to the power of number of network bits means 16 here minus priority bit. For the class B, what's the priority bit? 1, 0. What's the count of this? Nothing but 2. Here we are having 0 and 1. The count is 2. 2 to the power of 16 minus 2. Okay. 2 power 14. Around 16,384 networks are there here. And number of hosts, 2 to the power of number of host bits minus 2. Same. Okay. Got the point? This many hosts we can connect per network. Means this many 65,534 devices I can connect to the one network for the class B network. Okay. Next, see class C. We are having three network bits, three network portions here and one host portions. 0. Sorry, I couldn't get it. Please unmute and tell me 256.
256 are the assigned IP addresses, sir.
Sorry, where that? 256?
256 are the class C assigned IP addresses, sir.
2 power 24 minus 1, sir. Minus
2 power 24
minus 1.
minus 1. So you are okay. You are talking about the class A here. 2 power 24. This
2
one.
power 24 minus 3, sir.
Minus 3.
Yeah.
Sorry, what? I'm not getting you exactly what you are saying. See, yes, these 3 will be 24 bits. Okay. That's the thing you are saying?
Yes, sir.
Yeah. Okay. Good. Altogether, we are having number of network bits. I mean, number of networks will be 2 power 21. These many networks will be there in the class C. Okay. And number of hosts will be, as mentioned, 254 hosts per the network. Generally, they here see for each network, you said 256, right? Okay, it's correct. But in this, 2 IP addresses are reserved for the network ID and broadcast ID. Okay, we'll discuss what is network ID and what's the purpose of broadcast ID. Okay, which means, let's say, what's the class C IP address? 192.168. 1 dot some 0. Here, these 3 portions, this 24 bits will be my network portion, and this one will be my host portion. Okay. So for one network, what I can do, for one network, I can connect around 254 devices here. 254 devices connect. For the 254 devices, I can assign the valid IP address. We will see how we are doing that. What is network ID and
Sir.
broadcast ID? Yes, Anil.
Sir, actually, number of hosts here only 1, sir. So 2 power 8 minus 1. Is it correct or wrong, sir?
Where in the class C?
Yes, sir. Class C.
Okay.
Host, number of host.
Okay. What we are having number of host bits? Host bits are 8 here. Okay.
Yes, sir. Yes, sir.
2 power 8. What's the value of 2 power 8? 256, right?
Yes, sir.
From 256, we are subtracting 2 IP addresses. One is for the result for the network ID, other is for the broadcast ID.
Okay, sir. Yeah.
You got the point or not?
Yes, sir. Yes, sir. Yeah, got it. Yeah.
Okay. So this 254 means nothing but there will be 254 valid IP addresses are there in the class C for each network. This is a one network. Okay. Means, and the next one 192.168. Some 2.0 network. How many devices, I mean, valid IP address you have? Same, 254. Okay, these many valid IP addresses are there, which means you can connect 254 devices for this 192.168.2.0 network. We'll see that what is network ID and broadcast ID in the next slide. See here. Network ID and broadcast ID, or we can call network address or broadcast address. Okay. And broadcast address. So network address is nothing but IP address with all bits as 0 in the host portion. Try to understand. Let's say IP address with all bits as 0 in the host portion. We can call it as network address. Okay, or network ID. Let's see what is broadcast address. I will explain this. What is network ID? Broadcast address is nothing but IP address with all bits as ones in the host. All ones in the host portion. Okay, IP address with all bits as 0 in the host portion will be called as network ID. Okay, try to remember this. What you are doing, the host for getting so suppose what happens in an interview, the interviewer might give you that gives a IP address, and he might tells you that okay, what's the network ID for this and what's the broadcast ID for this IP address. He will ask you like that. Then you need to give him the, depending upon this, we can see how we can find out the network ID and broadcast ID of a IP address. So valid IP addresses lie between the network address and the broadcast address. Okay, for each class, for class A, class B, class C, I can explain you this. Only valid IP addresses are assigned to the hosts or clients, nothing but end devices. Okay, only valid IP addresses are assigned to the end devices, which means this network ID and broadcast ID are not allowed to assign for the end devices. It won't take. Okay, in class A we can see. So in class A, what's the octet format we are having? 1 network portion and 3 host portions, right? To get the network address, what we need to do? We need to make all these host portion bits to zeros. In the definition, you have seen this one, right? Please do respond. Yes, please respond. Okay. And in the broadcast address, what we are making? We are making all the host portions to ones. Okay. Let's say we are taking a 10 dot network, and we are making, you can see here, this will be my network address and this will be my broadcast address. And the in between will be my valid IP address. Let me know, have you understood or not up to here? So I can move forward. Okay, now good. So then, okay. Same, what we're making to get a network ID, we need to make whatever the host portions are there, these host portions, okay, depending upon the class, these host portions to be all zeros to get network ID. To get broadcast ID, what we are doing, we are making these host portions to all ones. You can see here the example. Okay. Okay. For let's say 10.0.0. belongs to a class A, right? These 3 octets are my host portion. So I made all them zeros. This will be my network ID. Okay. And to get a broadcast ID of this network, what I do, remaining these host portions, I make it all ones. If you convert all ones, what's the value you are getting here? 255, right? In the decimal, 255.255. Got it? Here you can see the host portion says 255. This will be my broadcast ID for the network 10.0. This 10.0 is a network ID. Class B, same. We are having 2 network portions and 2 host portions. So to get a network ID, what we need to do? We need to make this host portions as zeros, all zeros. Okay. And to get a broadcast ID, what we are doing? We are just simply making all the host portions to all ones. Got the point? You can see here, example, 172 is a class B. it will be my network address, because here these two will be my network portion and these two will be my host portions. So I'm making this host portions as 0 to get the network ID. So this will be my network ID. And here you can see the 255.255. These two host portions as all ones. This will be my broadcast address. And the in between IP addresses will be valid IP address. So like that, how many IP addresses we have? This will be my valid IP address. This valid IP addresses I can assign for the end devices. Come to the class C. Come here, we are having 3 network bits, network portions, 1 host portion. So to get a network ID, what we need to do? We need to make all the host bits to zeros. And to get the broadcast address or broadcast ID, what can we do? We need to make all the host bits to all ones. All host bits to all ones, right? This belongs to the class C, and this will be my network ID. This will be network ID, which means these 3 are my network portion. This host portion I am making 0. This host portion I am making 0, and I can say this is my network ID. And this will be my broadcast address or broadcast ID. Address or ID is same. Valid IP addresses. So how many valid IP addresses do we have? This will be, in total, we have 256 IP addresses. Okay. You have seen here, you can come here in the calculation part. How many you are having? 256. But network ID, we are using one for the network ID and broadcast ID. These two, you are subtracting 2 from this. In general, we are having in general we are having 256, but one is reserved for the network ID. One is reserved for the network ID. So minus from it. We are having 255 more. From this, one more is used for the broadcast address. So do minus 1. We are left over with the 254. These 254 IP addresses are valid IP address. Valid IP addresses. These valid IP addresses we can assign for the end devices. Okay. Let's see here. Identifying network address and broadcast address. So now tell me, what's the network address of this one? 120. The small exercise, we will end up with this. Let me know. So what's the network address or network ID and broadcast ID for this? Any of you, tell me now.
It's class
that's-
A, 120.
Yeah, it's a yes, class A.
One network and 3 hosts.
Yes. One network and 3 hosts.
Not and
Correct.
3. No, yes.
Your approach is correct here. Okay, next one. Now what we need to do? The remaining these 3 bits. This is a host bit, this is a host bit, this is a host bit. Yes, good, absolutely correct. So Naik. Yes. What do you need to do? You need to make this as this host portions as 0. So 120.0.0.0 is my network ID.
Network ID.
Yes. And what's the broadcast ID?
120.255.255.255.
Yes.
It's broadcast ID.
Yeah, great. Okay. You can see here. This is the broadcast ID and network ID. For the 172, let me know now. 172.16.1.1. or you can, if you're unable to, I mean, if you have any problem with the speaking, you can type it. We will finish this session and end it up.
I think it's class B.
Yeah.
2 networks
Yes,
and
it's a
2 hosts.
okay. It's a class B. Good. Yes. Now tell me, in the class B, how many portions we have? Class B network portions.
2 portions, sir.
Yes, good. 2 network portions and 2 host portions.
Host
Simply what you
portion.
need to do? You need to do the host portions to be 0 for network ID, which means 172.16.0.0 will be my network ID, and 172.16. In the host portion, to get the broadcast ID, what you need to do? You need to make all ones. The host portion should be all ones, right?
Yes,
You will get a 255.255.
255.
Yes, this is the value. And the same for the do the next one here. It belongs to the
Class A.
class A, which means same again. Class A. We need to make one network portion,
One.
remaining all are 0.
3 host portions.
Yes, 10.0.0.0 will be the my network ID. Okay, and what's the broadcast ID for this?
255.
10 dot
10 dot 255 dot
255 dot will be my broadcast ID. Great. The next one. Try out next one. We'll end up the session.
Class C, sir.
Yes, class C. Good. Now do it.
192 0.0.0
192 dot
0.0.0
0.0.0.
was the network ID.
Okay, network ID.
Broadcast ID was 190.250.255.255.
192.255.255. This is your answer, right?
Yes, sir.
You need a small correction here.
Here, okay.
See, for the class C, we are having 3 network portions.
Okay.
One host portion. Yes.
Yeah.
Yeah, very small correction. You need to.
Yes, sir. Only 255 is there.
Yeah, nothing but here. For this one, you can see here for the 192.168 dot 1.10 is the IP address you are having. For this,
Yes, sir.
the network ID will be what we there for this octet format? 3 network portions, 1 host portion, right? 192.168.1. What you need to do to get the network ID? You need to make the host portion as 0. Simply write here 0. For the broadcast ID, 192.168.1 dot. Now tell me, the host portion should be all ones, right?
Yes, sir.
Simply 255.
255.
Okay. Good. Now you'll know. Now you won't forget it anyhow. Okay. Same. The second one is class B, the 150. What's the IP address? 150.10.1.1, right? This is the IP address. Class B, we are having 2 network portions, 2 host portions. Therefore, what's the network ID for this? Speak out 150.10.0.0. And broadcast ID will be
150.10.10.255.
Yes, 255. That's it. Okay. Okay, we'll wind up the session today here.
Excuse me, sir. Can you please
Yes.
put a slide for class B network host? I will take a screenshot.
Okay. Okay.